All right, guys, this is Mrs. Allison. We are going to look at another type of solving quadratics. So far, we've talked about solving quadratics using factoring, solving quadratics using square roots, and we are going to look at solving quadratics using the quadratic formula. Now, the nice thing about the quadratic formula is it can be used anytime. But the primary reason it is used is because you have an equation that doesn't factor. Now, how do you know that? It means you have to try factoring it first, but the quadratic formula will work even if it is factorable. So the first thing we want to do to actually solve, to go through the solving process, is check to see if it factors. Factoring will usually be easier, especially if the directions say to solve by factoring. Otherwise, if it doesn't, then the next thing that we want to do is we want to get the equation into standard form and set it equal to 0. So let's remember what standard form looks like. Remember, standard form is the equation y equals ax squared. I think I'm going to run out of room here. Let's try this again. Y equals ax squared plus bx plus c. So we want it in standard form, and instead of writing it equal to 0, or to equal to y, we're going to write it equal to 0. So it's going to look very, very similar to how we started to solve by factoring. So the next thing I'm going to do is look at what my a, b, and c are, and now I want you to watch the video at the bottom of this page. It will show you what the quadratic formula is, and it gives you such a nice way to remember it.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So that's pretty epic, right? You can go back and replay that, and then you can sing along. It'll help you to learn it. So let's move on. All right, so let's look at a problem. We're going to look at it a couple different ways. As you can see here, I have the equation x squared minus 3x minus 10 equals 0. And what I want to do is I want to solve this. So the directions will say to solve. It will either just say to solve, or it will say solve by a specific method. Today, what we're going to do is we're going to look at solving by factoring and solving by using the quadratic formula. Now, I've listed the quadratic formula here, although I don't think it's fabulous because there was no way to notate the plus or minus. It doesn't normally look like that, just so you know what that is. All right, so why plus or minus in the equation? Well, let's think back to what we did earlier with solving by square roots, and remember that solutions are really x-intercepts, and so we should have 2 of them. And when we have to take the square root, our answer will be plus or minus. So let's start this equation, x squared minus 3x minus 10 equals 0, by using the quadratic formula. And then we're going to verify it using factoring. Okay, so let's identify, first of all, what our a, our b, and our c are, just like we did when we were graphing standard form. So we know a in this problem is 1, because that's the coefficient in front of the x squared. Our b value is negative 3, and our c value is negative 10. The quadratic formula is really just something where we plug numbers in and make sure we use good order of operations. It's kind of a plug and chug sort of equation. So let's look at how it works. All right, So we know the answers are going to be x equals because they happen to be the solutions to the equation, and the equation has x in it, and they are going to be our x-intercepts. So this equation says negative b. Okay, well b happens to already be negative, so this is going to be a negative negative 3, which is better known as a positive 3. Okay, plus or minus, and we are going to write plus or minus because we have two possible answers. The square root of b squared, so I'm going to do negative 3 squared minus 4 times a, which is 1, times c, which is negative 10. All of that over 2 times my a value. Okay, let's do some simplifying. We get x equals positive 3 plus or minus the square root of, remember negative 3 squared is 9, and I have a negative 4 times 1 times negative 10, which is going to give me a positive 40 over 2 times 1, which is just 2. So x equals 3 plus or minus the square root of 49 over 2. Now there's often times where we won't be able to find the square root of the number without typing it in our calculator, but we happen to know the square root of 49. So my equation becomes x equals 3 plus or minus 7, because the square root of 49 is 7, over 2. So I have two problems. I have the problem x equals 3 plus 7 divided by 2, and I have the problem x equals 3 minus 7 divided by 2. So my two answers are 10 over 2, which we know to be 5, and negative 4 over 2, which we know to be negative 2. All right, let's verify that these actually work, because this problem is factorable. So let's solve this one on the right, same equation, but let's solve this one by factoring. And remember, to solve by factoring, it still needs to be set up the same, in standard form and set equal to 0. So it is. So now I'm going to use my diamond because this does not have a greatest common factor, and my leading coefficient is 1. So my diamond problem is going to look for two numbers that multiply to negative 10 that add to negative 3. And those numbers happen to be a negative 5 and a positive 2. So I'm going to put those in my factors, x minus 5 and x plus 2, and they are going to equal 0. All right, then the zero product property tells me I'm going to do x minus 5 equals 0 and x plus 2 equals 0. Are you seeing it yet? I'm going to add 5, and I get x equals positive 5, and I'm going to subtract 2 for the second equation, and I'm going to get x equals negative 2. Hey, look at that. We got 5 and negative 2 using the quadratic formula, and we got 5 and negative 2 using solving by factoring. So either method works in this case. You get to decide which one you like, unless I specifically tell you which method you think is best, but really you get to choose. That's what's nice about it. So let's go on and try a little bit more challenging problem. Okay, so let's look at this problem. I have the problem 2x squared minus 8x equals 5. And notice I've given you the quadratic formula again. I will be giving you the quadratic formula on any test or quiz. I think it's more important that you know how to use it and understand what it's used for than memorizing it. Of course, you could always sing that wonderful song. So let's look at how we solve this problem. I notice that 2x squared minus 8x equals 5 is not in standard form. So the first thing I'm going to do is I'm going to put it in standard form by subtracting 5. Now, is 5 like terms with either 2x squared or negative 8x? No. Okay, so this is going to be the equation 2x squared minus 8x minus 5 equals 0. Now it's in standard form. Now if I have a preference and I'm not being told, I'm going to choose to solve by factoring. I personally think it's easier. So I'm going to check to see if I can solve by factoring here. I notice I do not have a greatest common factor between any of those three terms. And then I notice that the leading coefficient is more than 1. So this is going to be either factoring by using Xbox or factoring by grouping for trinomials. So the first thing I'm going to do is I'm going to make my diamond, and I'm going to look for two numbers that multiply to negative 10 that add to negative 8. Well, if we think about our factors of 10, the factors of 10 are 1 and 10 and 5 and 2, and there is no way to make 8 with those. So I know this problem is unfactorable, or what we would think to be prime as far as factors go, but that doesn't mean it doesn't have solutions. So I now know I need to use the quadratic formula to be able to solve this. So the first thing I'm going to do now is I'm going to list what A, which is 2, B, which is negative 8, and C, which is negative 5. Please do not lose your signs that go with those coefficients. Okay, so now I'm going to fill in my quadratic formula. The quadratic formula says x equals the opposite of b. So again, we have a positive 8 plus or minus the square root of b squared, negative 8 squared, minus 4 times a, which is 2, times c, which is negative 5, all over 2a, which is 2. So now I'm just going to do some basic algebra. So x equals 8 plus or minus the square root of negative 8 squared is a positive 64. And then I have a negative 4 times a positive 2 times a negative 5, which gives me a positive 40. So 64 plus 40, all over 4, 2 times 2. So x equals 8 plus or minus the square root of 104 over 4. That means I have two possible solutions. I have the solution x equals 8 plus the square root of 104 over 4. And I have the solution x equals 8 minus, because that's the plus or minus. Remember, we have plus or minus, which gives us one positive, one negative part of the equation. 8 minus the square root of 104 over 4. Here are my two solutions. They're not pretty, and we could find decimal approximations. We would just need to type this into our calculators. Okay? If you type this into your calculators, you should get the two values. X equals roughly 4.55 and x equals negative 0.55. Well, what does that mean for us? If we were to look at this graph, not knowing anything else about this graph right now, I know my x-intercepts would be the values at 4.55 and negative 0.55. They're the solutions or the x-intercepts. So feel free to watch this video as many times as you need to get help on the quadratic formula. The assignment that you're going to get for this section has solving in several different ways. I want you to show it by factoring, show it by graphing, which we talked about in the last video, solving square roots, and show it using the quadratic formula. So there will be several parts to this worksheet.